Hello children. The next topic what we are going to see is about linear momentum, Newton's first law and the effects of force and the types of force. Right? So in detail we are going to learn this. Now on explaining linear momentum, what is this factor called as? Now I will tell you two examples. Right? Now when you are walking on the road, a bike or even a lorry, okay, don't go for lorry, let it be a bike, right, which is coming in a slow speed, less speed, and it is coming and just hitting you here, right. Then now another example will give when you are playing a cricket, right, a ball is coming to you with a great speed. In these two examples, see, the bike is bigger in size, right? Even if it is bigger in size, if it is coming slowly, it won't hurt you that much, right? In a severe manner. But when a ball, though even it is in a smaller size, when it is coming with a greater speed, if you don't have a proper catch, it may even create a fracture in your hand, right? So what is these mysterious relationship between mass and velocity, children? That is, bike, that weight or mass is bigger, right? But speed makes it less effective. Here the ball is smaller, but the speed makes it more effective. So we need one separate precise term to explain about the combined effect of mass and velocity, that is speed in a form. That combined term for mass and velocity is called momentum. If it is acting on a linear way, straight way, then it is called as linear momentum. Its symbol is P, children, small p. So don't confuse it with a capital P. Capital P goes for pressure. So it is P, it is the combined effect of mass and velocity. So it is the combined product. So P is equal to mass into velocity. So what is linear momentum? The product of mass of a body and its velocity give its magnitude. Magnitude I had already explained you. It is the numerical value of the term involved. Here the term involved is momentum. So okay, magnitude I had told you what will be the direction. It will be in a direction where along with the force direction. Okay, in which direction the force is applied, in that direction only momentum also will act. Right. So what is momentum? Momentum is the product of mass and velocity. So it has magnitude and it has direction also. So it is a dash quantity. It is a vector quantity. Right. So come, let us go into the unit. Already I told you definition means definition, formula, unit. Definition I told you, it is the product of mass and velocity. And what is its unit? Formula I had given you, P is equal to mv. Here mass, unit of mass is kilogram, unit of velocity is meter per second. So what is unit of linear momentum? It is kilogram meter s power minus 1. Correct, no children? Correct pronunciation? No. Kilogram meter per second. No s power minus 1 and all. Right? So this is an SI unit. Now in CGS unit, gram centimeter per second. Okay, children? Alright. Now we are moving to the second point, Newton's first law. So in the first video I have told you, force is not only just push or pull, it needs some detailed explanation. That is what is given in the first law. Now here, these 2 points, first law and effects of force, I had combinedly given you here. Right? Now what is the statement of Newton's first law? I'll tell you the statement and then I'll move to this, right? Every body continues to be in the state of rest. What is the next state? State of uniform motion. Recall Galileo's state of earthly bodies. So every body continues to be in the state of rest or state of uniform motion unless, and one more word to be added, state of rest or uniform motion in a straight line unless it is compelled by an external force. So shall I say it again, children? Every body continues to be in its state of rest or state of uniform motion in a straight line unless it is compelled by an external force. Right. So now the law itself states what are the effects of force on a body, and it explains the definition for force. Now I had given the key terms of the law and I had defined the force here in relation with its effects on a body. Right. Now what I said, every body, now you have to go in a reverse way, unless it is compelled by an external force. So when a force is acting, a body changes from the state of rest. Am I right from the statement? Unless it is compelled by an external force, this is how we completed the Newton's first law statement. So when a force is applied on a body, the body changes from the state of rest. So what will happen? The force will produce motion. It will produce or try to produce motion on a body. And then when a force is applied, it changes the state of uniform motion of a body. So when a body is moving, then only it will be in uniform motion, right? So when a force is applied, what will happen? A body in uniform motion will be stopped. So a force can stop or try to stop the moving body along a straight line, I told in the statement, right? So what will be the effect? When a force is applied, the straight line direction can be changed. So now can you define the force? Force is again push or pull which produces or tries to produce motion of a rest body and stops or try to stop a moving body, or which will try to produce change in the direction. So we have combinedly learned the statement of the first law and the definition for the force in terms of its effects. Now again I say the first law, children. Every body continues to be in its state of rest or of uniform motion along a straight line unless it is compelled by an external force. Define force now. It is an external push or pull, number one, which will try to produce motion in a body, which will stop or try to stop a moving body, which will change or tries to change the direction of a body. Right. Now here by these definition, here force very well it will have some value, right? So it will have magnitude. It is measured in Newton. What is the unit of force? It is Newton. So it will have one numerical value. It will have magnitude. And here it changes in direction that we are learning. So force will have direction. It is very specific about its direction. So it have both magnitude and direction. So what type of quantity is that? It is a vector quantity. What is its unit? Newton. Right. Now depending upon the direction in which the force are acting, right? So it is categorized into two types, like parallel force and unlike parallel force. So that is what I have in simple diagram I had schematically represented here, right? So first let us explain what is like parallel force. When two or more, here I had represented only two forces. You can have more forces also. When two or more equal or unequal forces. Here I represented like equal forces only, but it may be unequal forces also. If two forces in general act in the same direction on a body, then that type of forces are called as like parallel forces. What is very important? Same direction. One example you can say, right? when many of you join together and push a table. So all of you will apply the force in one direction. Then it is called as like parallel force. Now what is unlike parallel force? When two or more like equal or unequal forces act in the opposite direction on a body, then that type of forces are called unlike parallel forces. Okay children, so these are the points to be remembered now. Very very important points you have to learn today. So linear momentum, based on this only we are going to derive the next one, second law. And rate of law of conservation of momentum is also there. So important questions we are going to learn based on these concepts. So learn well about these concepts. Take down the questions children. Define linear momentum. So it is a package. What is the package? Package comprises of definition, formula, unit. Right. Now next, state Newton's first law. Then define force. That define force you can ask in another way also. What are the effects of force on a body? Both the questions will have same answers only. Don't get confused. Right. This you can ask as a fill in the blanks. Right. Unit of force is dash and it is a dash quantity. Right. Next question. What are the types of parallel forces? Because when I give force, you may get confused with the general classification. Muscular force, gravitation force, like that. So have the question specific like this. What are the two types of parallel forces? Explain with examples. Okay children, thank you. Prepare these concepts and be ready for the next topic. Thank you children.